Hi, I'm Leo from Colab Cambodia, and this is the second video of this series. Today we're going to talk about how to draw a circuit diagram for a simple switching LED circuit. So let's get started. We have a few components with us. We've got a 9-volt battery, we've got a resistor, we've got an LED, and we've got a momentary switch. So our challenge is to draw a circuit diagram of a circuit which involves all of these components in series. So let's start. You should remember that the circuit diagram for a battery is a pair of lines, one longer than the other. For a 9-volt battery, that actually consists of 6 smaller cells inside it. So when we draw the symbol for a battery, we will draw 3, 4, 5, 6 single cell symbols in a row. If you like, you can mark on which side is negative and which side is positive. And if you're sensible, you'll write in 9 volts across the top of the battery so we know what the value is. All the components in a circuit diagram, as in a real circuit, are connected with wires. The symbol for a wire is just a line. Typically, you would draw straight lines with right angles. If you want to, you can draw them curvy as well. That's going to lead to diagrams which are more difficult to understand when you start designing things that are more complicated. So let's stick to straight with right angles. Our next component in line is going to be a switch. For all of these components, it doesn't actually matter which order they come in, but let's stick to this one for now. The diagram for a switch with a single line going through it looks something like that. The wire comes out the bottom again. This is the symbol for a switch which is normally open. So for a momentary switch, normally it does not conduct electricity. When you depress the button and hold it depressed, it will start to conduct electricity. That's the same as this line being moved into contact with that point. When you let go again, it opens the circuit back up and electricity stops flowing. The next component is our resistor. You should remember that a resistor is a device which eats power. It prevents too much current being transmitted through a circuit. And the symbol for a resistor is something like that. Again, if you're sensible, you will mark down the value of the resistor so that you can rebuild it next time. In this case, I think it's about 220 ohms. Let's bring these lines up so that they're in line. And the final component of our circuit is our LED. This is a 3mm through-hole red LED. And it's important to remember that these devices are polar. That is, if you put them in the wrong way round, they will not conduct anything at all. You won't get any light. If you put them in the right way round, they'll be very happy to conduct. So much so that you have to have them limited by this resistor. So let's put that in. The symbol for an LED is a triangle pointing in the direction of current flow, that is from positive to negative in a circuit diagram. And it's also got some little arrows coming off it, which means light. So there's our complete circuit diagram. Let's take it from the top, from the positive side. 9 volts here travels through the LED. If you remember from the last video, we said an LED might eat between 1.5 and 3 volts by itself. Let's say it's 3 to make this easy to calculate. So this bit here is taking up 3 volts of the circuit. We get down to here, we're left with 6 volts. 9 minus 3 is 6. The remaining voltage is going to be eaten by this resistor. So across this is 6 volts, and by the time we get to here, we're at almost close enough to 0 volts. The switch there means that this battery will only power the LED when you are pressing the button to hold the circuit closed. Otherwise, the voltage across this whole wire is 9 because it has nowhere to fall to, and the light doesn't light. So there's a very simple series LED switching circuit with a resistor. Next up, I'm going to show you how to convert from a circuit diagram into a real-world circuit using a program. Thanks.